Thank you. My name is Vijay Naik. I'm from IBM Research. Good afternoon to all of you. I'm going to talk today a little bit about cloud service broker in hybrid cloud environment, hybrid IT environment. This is a new up-and-coming area, much more pertinent to enterprises. And managing these hybrid clouds, managing cloud broker is becoming quite important to many enterprise users. So I'm going to talk about how cloud broker capabilities can be incorporated in OpenStack type of environments. Many developers, users, lines of businesses are trying to use many different types of cloud provided services. They want to use this so that they get the speed, agility, and best of breed. Whereas traditional IT admins, CIOs, they want to make sure that regardless of what services are being used, those services comply, there is certain kind of control, they can measure the usage, etc., etc. Regardless of which service provider is used by developers, IT admins want to manage those and manage those so that there is compliance, there is cost optimization, and there is a consolidation of spending so they can do a cost drill down and chargeback and so on. So that's where the broker comes into picture. So you may have multiple cloud providers and also on-premise private cloud, and they want to provide these services to their users in the form of a catalog. Naturally, there is some tension among lines of businesses and IT admins, and there is a need for balancing this tension. Users, of course, want to have flexibility. They want to use the services they need, and the central IT want to have visibility into what services are being used, and then manage those in a compliant manner, apply patches, make sure they are secure, and connectivity is used according to the IT policies. So the cloud broker is the one that provides the kind of intermediation necessary so that the users get to use what they want and the IT admins get the central control. Okay. So here are some example configurations. Configurations that different roles might be using and some scenarios around those roles. So for example, a line of business developer may want to develop some app, do some testing, and then deploy those in production mode. And in each case, during development phase, during testing phase, during deployment phase for production, they might want to use different platform. And the platform choice may be determined by the IT policies. IT admins, on the other hand, want to view all the services that are being used by different users from a single pane of glass and manage those in a centralized way, make sure they're patch compliant, make sure the firewall rules are followed, etc., etc. And then CIO, on the other hand, may want to do some cost drill down, may want to figure out that the lines of businesses are staying within their budgets and set some policies about the quota is being followed and so on and so forth. So the cloud broker is the one that can bring about this kind of central control, and administration of the cloud broker might be performed through a central admin person. So what this picture is showing is there are various different kind of functions the cloud broker might provide to bring about this kind of central control. That includes cataloging, that includes composition, that includes orchestration. These are the kinds of things that the users are interested in making use of the services, whereas the IT admin want to use IT management services that are applied across different providers and the governance that the CIO might want to use. Okay, so in the rest of the talk, I'm going to focus on three of these components. The cataloging services that are being used by the users, the composition aspect on top of these catalogs, and then the orchestration. And show you how different roles can make use of these to perform their actions. So the cataloging, dynamic cataloging of the services means users are able to see the single catalog, the services they are allowed to use for a particular project, for a particular development purpose. These could be based on the location, it could be based on the phase of the workload. So for example, for development, they might be asked to use a public cloud in a certain location. For QA, they might be asked to use another kind of cloud. For production, it might be a managed private cloud, and so on and so forth. So depending on the type of project they're working on, depending on the phase of the workload, depending on time of the day, etc., a different policy might kick in, and you want to use a catalog to bring in this kind of services that are allowed to use, and then the user simply selects the service and does deployment, and the underlying cloud broker handles access to that cloud, deployment, provisioning, and bringing up those services so that regardless of where it is deployed, it comes up, runs, and then the IT admins are able to see it, manage it, and so on. So this catalog of services is something that the cloud broker handles transparently, taking into account policies, taking into account preferences, and also it is dynamic based on the services that are being selected. It provides the next set of services that are available from that service provider to make that composition possible. So what is this composition? So the composition includes using the services provided by the service providers, and the service providers could be multiple service providers that the enterprise has subscribed to, and then based on the selection of a particular service provider, the user may want to create compositions on top of that. So for example, they might use compute storage network from one of the service providers, build a software stack on top of it, and then use that composition for deployment subsequently. That deployment may have to take into account some of the IT admin policies, such as applying certain patches, using certain operating system or certain flavors, etc. So that's all part of the composition aspect. Some of that needs to be transparently handled based on the cloud provider. So again, that is the aspect cloud broker handles. A third part of this is the orchestration. So once you have a composition selected, it needs to be orchestrated. So deployment, after the deployment, you want to handle the runtime environment, handle the life cycle of such a deployment. So for example, you may want to do elastic scaling based on the state of the system. So if the load goes up, you want to be able to scale it up. Load goes down, you want to scale it down. And depending on where it is deployed, you want to use the native services to do the monitoring, to do the scaling, to do the failover recovery, and so on and so forth. So that's all part of the orchestration. Again, this orchestration, handling that transparently across different cloud providers is the job of the cloud broker. So now, given all of these services that the cloud broker does, let's look at how we can enable this in OpenStack. So enabling cloud broker in OpenStack means two things. One is from the user consumer perspective, the user is interacting with certain aspects of OpenStack. So these include various dashboards, UIs, Horizon UI, for example, the heat engine, and so on, various CLIs. Then on the other hand, you have multiple service providers providing compute storage network, images, monitoring, etc., etc. And some of these might be OpenStack based, some of these may be non-OpenStack based. So when some of the service providers are non-OpenStack based, they may have their own proprietary API, and those need to be handled so that on the user side, the users get a uniform view of the world without having to know all the different APIs, access controls, and so on. So the cloud broker acts as an intermediary between the provider and the user services. So that aspect needs to be part of the Cloud Broker enabling. So the intermediary services that are in Cloud Broker include aspects such as credential management. So different clouds might have their own credential management, access control. Depending on the particular service being selected, those specific credentials need to be invoked. There might be policies in place. They need to be invoked and create a catalog. Once the user selects the specific service from a specific service provider, subsequent filtering may happen, and subsequent policies may have to be applied to comply with the IT services. And then when the deployment takes place, maybe certain management agent need to be installed. So all that is part of the intermediary services. So the OpenStack extensions, in addition to things like the policy engine, things like the usage metering, things like the management for monitoring, etc., you need certain extensions. And these extensions include extensions to Keystone and extensions to heat and hot engines. So in current Keystone, especially in Kilo and Liberty, there are Keystone Federation capabilities incorporated. However, they are much more tightly coupled. For a Cloud Broker-based federation, you need much more loosely coupled extensions. So these enable at the user level or tenant level, project level, ability to exchange tokens across different keystones. And also these Keystone federations need to be set up in a much more dynamic manner, so that when on the identity provider side of the Keystone, that means on the enterprise side, when the administrator or a project manager sets up the credentials for certain users to use a certain cloud provider, the Keystone on that cloud provider side need to be able to recognize these user requests and be able to provide tokens that on the Cloud Broker side, the heat engine, the Horizon UI or Nova or what have you, those controls should be able to talk to the service provider's OpenStack components. And when the service provider is a non-OpenStack provider, then there are different credentials. So the Keystone on the Cloud Broker side provides these tokens. Those tokens need to be transformed into the credentials that the cloud provider, the service provider, is capable of understanding. So for example, Amazon or SoftLayer, they have their own credentials. Those credentials need to be managed through the tokens provided by the identity provider. Similarly, on the heat and hot side, there are certain extensions needed so that you can create these templates and stacks, compositions, using common resource types, common across all different service providers. And those common resource type can be then mapped onto the specific service provider resource types transparently by the Cloud Broker. So this is some of the capabilities the Cloud Broker handles under the covers. Now, there are several aspects I talked about. Some of these aspects are incorporated in IBM offerings, in particular IBM offerings around IBM Cloud Orchestrator. So today, some of these Cloud Broker capabilities are in place, and we are working towards making these more wider in applicability and also bring them into OpenStack. So thank you. Thank you for your attention.